Okay, I'm just going to run through the difference between a rational and an irrational number. So basically, a rational number can be written as a fraction. So if you can write it as a fraction, so in the form of a over b, where a and b are integers, then it is a rational number. Okay, so any decimals like this that are terminating are rational. Any whole numbers are rational because you can write them as fractions. Percentages are rational. Fractions are rational, obviously, because you can write those as fractions. Now, recurring decimals, they can also be written as a fraction. I don't know if you remember the method of writing them as a fraction, because we did this quite a while ago. But if you let x equal 0.3333, and then you multiply it by 10x, that moves the decimal point one place to the right, so you get 3.33, ... Then when you subtract 10x minus x is 9x, 3.33 minus 0.33, the 0.33's cancel out, you get 3. And then that's times 9, so if you divide by 9, it equals 3 on 9, which is 1/3, which is definitely a fraction. Now, if you just got your calculator and you just went 33333 and put lots of 3's in across your screen, then press equals and SD, then it will go to 1/3, which is a fraction. So recurring decimals are also irrational. Like 40,000 would be, are also rational, sorry. It'll be rational. So this is a rational number since it can be written as a fraction. Okay, so any of these, like 7 is rational, that's rational because it's 7 on 1. That's 1 on 10. 3, 2, 5 on 1, 2, 3 on 1,000. 1, 8, 3, 6, 7, 9 on 1, 0, 0, 0, 0, 0. Okay, 0.3 recurring is 3, would be 3 on 9, which is 1/3. And 0.1111, that is 1/9, because if you multiply by x equals that, multiply by 10, you get 10x, which is 1.111. If you subtract these two equations, you get 9x, they go out and you get 1. So x is 1 on 9. But you can just get your calculator and press the SD button after putting it in, and you'll see it can be written as a fraction. So further on, if you have square roots, like root 2, okay, you put that into your calculator, then that would be, root 2 would be 1.41421356 and keeps going. Use your calculator to do that. And you notice it goes on forever and ever after the decimal point. Okay, it cannot be written as a fraction. So therefore it is not rational, and the name that we call something that is not rational is irrational. Okay, so root 9, that will be 3, and yes, see, that will be rational. Root 7, that will go on forever after the decimal point. Root 5 will go on. That's 2.2360060, Just put it in your calculator. Root 31. See, that will be 5.56776436. It keeps going on. It cannot be written as a fraction. So we actually call these surds. Okay, and the surds that you can't square root, okay, they are irrational. The other irrational number you come across is pi, which is 3.14, and then 1559265, and it goes on forever and ever after the decimal point. It doesn't repeat and it doesn't reoccur, so it is also irrational. So if you're given a list of numbers and you're trying to see whether they're irrational or not irrational, 17 on 19, root 2, 5 on 900. If it can be written as a fraction, you know, if you can find the square root of it, it will be rational. But if you can't find the square root of them, then it won't be irrational. So if we look at all like these ones, the third, that one, root 9 is equal to 3. That one, okay, so you've got the 17 on 19, that's a fraction. 5 on 900, root 16 is 4, root 100 is 10, and that one is also a fraction. So all of these, that's 3, that will be 10, 4. See, 4 and 10 and 3 can all be written as fractions. They are all rational numbers. But the ones that are irrational is the root 5, the root 31, and anything in terms of pi. They are all irrational.